Leetcode 929, unique email addresses. Every valid email consists of a local name and a domain name separated by the and, the at sign. Besides lowercase letters, the email may contain one or more periods or pluses. For example, alice@leetcode.com. Alice is a local name, leetcode.com is the domain name. Okay. Add periods between some characters in the local name, part of the email address. Mail sent there will be forwarded to the same address without dots in the local name. Forwarded to the same address without dots in the local name. This rule does not apply to domain names. Okay. alice.z@leetcode.com and alicez@leetcode.com forward to the same email address. Oh, okay. So it just removes the dot, I guess. Yeah, okay. If you add a plus in the local name, everything after the first plus sign will be ignored. Okay. This allows certain emails to be filtered. Note that this rule does not apply to domain names. Okay. For example, m.y plus name at email.com will be forwarded to myemail.com. Okay. It's possible to use both of these rules at the same time. Okay, so that's an example of that situation. We're using both the rules at the same time. Okay. Given an array of strings emails, where we send one email to each element in emails, return the number of different addresses that actually receive mails. Okay. Some examples. So test.email, this would just be test email at leetcode.com. This would be test email at leetcode.com, test email, and then this is different. So it doesn't like remove the periods in the domain name, yeah, but only in the local name. Okay. So test email, and so it's just, since these are the same, like they resolve to the same address, when you apply the rules, there's only two. Okay. And for this one, A at leetcode.com, B at leetcode.com, C at leetcode.com, there's just 3 unique addresses. Okay. Got some constraints here, so I'm going to paste in my PDAC. Okay. Cool. So let's read the constraints. So the length of the input array is always going to be between 1 and 100. The length of the individual email, like addresses, is that same range of lengths. They consist of lowercase English letters, plus, period, and ampersand. Okay. So, which our input is an array of strings, string elements, and each element contains lowercase, or can contain lowercase English letters, period, plus, and ampersand, and at sign. Yeah, where's that? Okay. Contains exactly 1. Okay. Each email has exactly 1 at sign. Okay. All local and domain names are non-empty. Okay, so there's always something. So local domain names are never empty strings. Non-empty, okay. Local names do not start with the plus character. Okay, so if we were thinking about like an edge case here that they're saying would not be a valid input, I'm just taking that to mean like if this was an element, this would not be contained in our input array because it starts with the plus symbol. Yeah, or the plus character. Then domain names end with the .com suffix. Okay, so that's a constraint. I think that means that all of them are always going to end with a .com suffix. I think that's fair to say. So really, this problem boils down to like filtering, or I guess modifying strings in an array, essentially like kind of cleaning them. So basically we need some sort of approach where we can look at each element in the input array in emails and check to see, and I guess apply the rules. So I think really we're not concerned with the domain name so much. We really are just concerned with the things to the left of the @ sign. And then we just want to return some number, right? So the number of unique addresses which receive mail. Okay. So how do we want to do that? And this is always going to be a number between like 1 and 100. Yeah. It will never be 0 or exceeding 100. Okay, so we're to just kind of review the rules here. Let's think about that. So this would be invalid test case. And okay, so let's think about the rules. In local name, if there's like a situation where there's a period, so I guess periods can be ignored. Okay, when we like construct the string, and then basically so that can be ignored when we're building the strings, and all characters in local name following can be ignored. Okay, or like removed, maybe we can say it like that. Removed. Okay. Okay, so it seems like what we need to do is split the string in half, basically around like this point, so we can essentially just like chop off the tail of the string starting at the ampersand, and we just save it for later to then be appended as we build our result array of unique addresses. And most of the stuff we're going to do is just going to be focused on producing the eventual local name for each of the individual elements and emails. So let's think about how we would go about doing that. So essentially that's our summary. We're essentially just breaking strings into sections and modifying and applying some rules to the first half of the split string element. So like when we're talking about splitting it, it's again just splitting it in half at the ampersand, or I'm sorry, at the @ symbol, and then just performing some operations on this string here. And so I think that just looks like removing any periods. And so essentially we want to, so for first half, we just want to like remove all periods and chop off any characters which come after the plus symbol. Yeah. So if we're to like think about the steps here, we need some sort of way to traverse input array of strings. So I'm just thinking like a for loop or something. And we also need, maybe, I think we're gonna build up a result array. So maybe this can just be called declare unique addresses. We'll just do that. And that'll just be an empty array to start. And we essentially just want to traverse the input array of addresses. And then essentially for each element, we want to chop tail from, or chop tail from @ to end. So we're just thinking like slice. And then save this in a variable. Save for later in maybe like end or just domain. That'll just be the variable name. And then once we do that, we want the we want to slice. Yeah, so then slice from 0 up to not including @ and that's going to be, so save in local. Okay, and then we need to essentially apply those rules that we were talking about, so ignoring the 0. And I think I'm trying to think of like an efficient way to do that. I think we want to just traverse local and chop, and so traverse local characters, and essentially what we want is to if the character is that, we just want to ignore it, I think, or just remove it. Do we want to replace? I'm not sure if that's very efficient. I think we're just going to build up another string. So we'll call this new. We'll declare a variable here. Declare new local. Okay, that's just a variable. And then we want to traverse local's characters. And if the current character is a period, we just want to skip it. Skip that character. If the character is +, then we just want to stop traversal. And yeah, just stop traversal. And then otherwise, we just want to concat current character in local to new local. Okay, so then once we exit this loop, we'll have built up the first half of the email address. And then once we have that, we just want to essentially concatenate new local with domain, and then just push that into the unique addresses. Unique address, okay, array. And then from there, we just want to, once we have that, technically this is kind of a poorly named variable. Maybe we'll call it, it might make sense to call it, well, do we want to store? We could technically store them in Yeah, we could store these in like a object or something. So maybe we'll declare. I think we can leave the variable name. We'll just use an object instead, and then instead of pushing it, we're just going to add it to the object, which is I think probably more efficient and will also mean that we don't have to worry about duplicates. Yeah, so from there, so okay, so concat new local and domain. We want to add this string, this address to unique addresses, um, and we can just maybe have like some arbitrary value like true or something when we add it, and yeah, that should be fine. So then we just want to essentially, do we want to get this? I guess we could use a set object and then just get the size. Yeah, I think we'll use a set here. So then we can just call, I think you can call size on set. Yeah, and then we don't even need to worry about giving it a value. We can just use it as a set as opposed to like a normal object. Okay, yeah, that should work. And then we'll just take or just return size, or return unique address size, and that should get us through to the end of the solution. So looks like we're at about like 13 minutes left. So I think I'm gonna start coding. Yeah, I think I'm gonna start coding. Now let me just move this up. Okay. So let's just follow our steps. Just starting on line 27. And I think we choose a for each. Yeah, we'll choose for each. So we want to traverse emails, and this is going to be an address. Okay. And on each address, we're going to chop the tail. So maybe do we need to get the last? Yeah, I think we need to get the index of. Ooh, this could be kind of inefficient. Okay, we'll just get index of at sign. Okay, and that will just be, there's only ever going to be one, so we can just use either of them. So we can just do address index of, and it will just be at sign. So that's going to give us the index where that string exists in our address. And once we have that, we need to essentially chop the tail from that index to the end. So we'll just call this domain. Okay, and then it's just going to be address slice from index of at sign up until the end. So we can just leave it like that. And now we need to get the, I'm not even sure if we need to do this, because we can just, well, yeah, I think we might have to do this actually. So let's declare another variable. This will be local, and that is essentially just 0 up to that index. So it would just be address slice from 0 up to index of at sign. Okay. Now we have some variables and we have split it up. Let's think about what we need to do next. So we need to declare new local. So just declare that variable new local, and we'll just initialize that to an empty string, because that's what we're going to just be concatenating characters to. So we need to traverse the locals characters. So we'll just use and we want to use a normal standard for loop because we want to be able to break out of it if we reach the plus symbol. So we'll choose normal for loop. I less than address, or I less than local length, and then I plus plus. Okay, so then we're traversing those elements, so then just declare another variable. So that'd be our current character. And then if the character is period, so if character is equal to period, we can just continue. If character is equal to the plus sign, we can break. And if, and then I guess this is really just otherwise, so we can just concatenate current character in local to new local. So we'll just do new local plus equals current character. Okay. Yeah, and then from there, we can just, we want to add it as well. Yeah, we want to add that to unique address upon each iteration. So we're just gonna add that to unique address. So uni address. Oh, and we need to actually append. Yeah, so I think we missed a step here. New local and domain. Okay. So here we're adding it to new local, and then now we need to append or concatenate domain with new local. So we can do that by, I think we can just do this. Add, and then it will be new local plus domain. Okay. So then we're adding that entry to our set. And then we just want to return the size of the set. Okay, so that should be all the unique addresses. Let's think about if we walk through this example. Let's just think about this example. Okay, so we'll just paste that up here. And I know we're getting kind of close to 30 minutes, but bear with me. Okay, so we're creating the set object, and then we're traversing this array of emails. And so we get the index at that sign. So, or we get the index of the at sign. So that would be in this first one. Oh, four. Oh, wait. I don't actually want to count this out. What is it? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it's at the 15th index. So, index of at sign is just 15. Okay. And then we're slicing from 15 forward. So it would just be this. So that's what domain is. Okay. And then we're getting local. So we're slicing up to index of at sign. So this should be just this portion of the string. Oops. This portion of the string. ALEX, yeah. The test, email, Alex. Okay, cool. And then from there, we're traversing these characters. So for the first one, good. Second one, good. Third one, fine. We're skipping this character, so we're not adding it to new local. And then we add all of these characters to new local, and then we just chop the rest of that off. We don't care about it. That's here where we're breaking out. So that should work. I feel like that should work. Let's take a run and see how we did. Okay, great. So we're passing the initial test case. Let's take a look and see how we did with the other test cases. Hey, first time. This was a fun problem. I was concerned by the efficiency of all of these operations, because this is technically O of n squared for time complexity, because we have a for loop nested inside a looping structure for each that, you know, touches every individual element in the array. And I mean, these numbers, like, sometimes it'll look like, okay, I'm like really fast or I'm really slow, but they're like wildly inconsistent from what I've read and also from just what I've experienced. So I wouldn't pay too much attention to them, so long as you're passing, and it's not, you know, reaching the time limit exceeded point, you're doing well. So yeah, really happy with my performance on this problem. I think my PDAC was pretty strong, and it's not really that wild of a problem. I'm sure there's like a more efficient approach. I just wanted to do it in like a um, really straightforward way that splits like the various operations, and sort of like packages the code in like a fairly accessible way. Because I think for me that's a huge point of like this whole practice, is just like make it understandable to others, because I'm preparing for an interview. So yeah, thanks for watching. I'm gonna call it. Peace.